Welcome to another tutorial on Matlab. In this tutorial series, we are looking into the basic understanding of Matlab scripting. And in this particular video, we will be looking into what is basically a symbolic toolbox and how we can use symbolic toolbox to solve equations in real world scenario. So coming to the agenda for this particular video. So first we will discuss on what is basically an equation, which we already discussed in our last tutorial. But we will see once again in this particular. With that we will start, and we also need to understand like what is the real scenario in which we can apply such equations in um, solving problems, right? And how we can simplify the equations using the MATLAB tool, and how we can create system equations. So we will also study like what is basically a system equation, and also we will try solving the system equation with the help of MATLAB as a tool, using the symbolic library of MATLAB. And at the end, we will conclude on the same. Okay. So consider a group of scientists, right, who are dealing with a complex problem, maybe in the field of chemistry, right? So they want to analyze some reactions, right? And based on that, they want to develop some equations before they proceed further with the implementation, right? So what basically will happen if they mix particular mixtures together, and based on that, like, can they develop what they want to develop, right? So as we already know, right, so there are two types of things that are present in math. One is basically mathematical expression, which is this one, and we do also have equations which equates to something, right? So this is about the difference between expression and the equation. Now consider the task that they want to do in this case, right? So they are discussing, but they are not able to conclude on something. So they find a checklist, and based on that checklist, what are the things that they need to do is to complete the task which are mentioned here. So first, they need to simplify the equation, and then they need to create the system equation, right? And then they want to solve that equation. So this process need to be repeated over and over again, right? So in this case, like, it is very difficult to solve the equation repeatedly for multiple scenarios, right? So because of this, they were stuck, and now they don't know what to do, because to start the experiment, they need to know like what is the outcome for this particular experiment. So after all these recurrent discussions with his colleague, he was sitting alone and was worried like how he can solve multiple equations in a repeated way to get and reach to a desired solution. So, based on this, he was doing some research in the internet and found that MATLAB offers a tool which is called Symbolic Toolbox, which is used for solving equations, or any number of equations in an automatic way using the environment offered by MATLAB. So, coming to the scenario, in this case, he tried something and come up with the solution at the end. And at the end, they won a Nobel Prize, and they were a lot happy. So basically, how the scientists won the Nobel Prize by solving all these equations in a repeated way. That is a key point which we can think about, like how MATLAB can be used to solve such complex equations, right, in a repeated way. So in this case, we will take a small example, and we will try to solve all these problems which they are covered in the scenario, right? Simplify a given equation, or create a system equation, and also solving the equation. Okay, so let's do it one by one. So first is simplifying the equation, right? So to simplify a equation, you need to create the equation. So the first thing is to create the equation with the relevant variables. So here we defined all the symbols using the SYMS library, and then we create this variable z, which is basically x cube minus 1, equal to a plus 3 into a minus 3. So this is the equation that we developed. Along with that, we want to now simplify this equation. So if you simplify the equation, then you will get the outcome in the form of solve, right? So let's clear everything from the previous program and try to execute the code for simplification, right? So this is the code, and just press Control Enter, and here you will get the solution as simplified solution as um, a square equal to x cube plus 8. So this is the simplified version of this. See, it is very easy now to simplify anything. If you just give a factor wise multiplication equation, then you can convert it into a summation equation using a simplified command using MATLAB symbolic library. Now, the next problem which we need to solve is to create the system equation. So basically, a system equation contains a good amount of polynomial, and usually the equation contains a defined variable which has multiple powers, like a Lagrange series, right? So it will have one particular variable raised to multiple powers, and add it up, and you need to create something out of that. So that can be done with the help of this simple example, right? So you just need to create a vector in which the first element is the highest power coefficient, next highest power, and the lowest power coefficient. And using this, you can create your own polynomial by evaluating this. So if you evaluate this, then you can see a is the vector that we created, and now b is the polynomial. If you see the polynomial, right, so this is how it looks like. And you can see the first coefficient is 1, second coefficient is 2, and the third coefficient is 3, which is same as this one. Now the reverse is also possible. Okay, so suppose you are being given with the equation already, and you want to extract the coefficient from the same. So that can be done like this: just right click, evaluate, and this command is called sim to poly. And with this, you can see the coefficients got extracted, and here we pass the variable b, right? So variable b is the expression that we already have, which is the polynomial, right? So with the help of this, you can do the reverse, right? So you can create polynomials with vector, and you can also extract the coefficients with the help of this symbolic toolbox. So this becomes more easy to solve and put it in a matrix format, or do some manipulation by collecting these coefficients of the different powers, right? So the next problem that they want to solve is to solve the equation to for a defined solution, right? So for that, there are two types of methods available, right? Either you will have an expression, or you will have a equation. So to solve a equation, there will be a different method, and to solve a expression, there will be a different method. So to solve the expression, first you need to create the expression. So you are creating the expression like this, and then what you need to do, you need to use the solve command to solve the expression. So this solves the expression. and you will get the outcome like this. So sol E is 3 in this case, because you already know that this expression equates to 0. Okay, so that x equal to 3 in this case, because x minus 3 equal to 0. So this do not contain multiple variables, right? So this contains only one variable which need to be solved in this particular expression. But suppose you want to have multiple variables in that particular expression, like a, b, c, and x. So that will be solved using the equation format. So in this case, like a x square b x plus c, right, equal to 0. So this is the basic quadratic equation that you usually see, right? So to solve this equation, it will take a lot time, and at least 2 minutes or 1 minute, right? But this can be done within some seconds. So how you can do that? You can use the solve. Okay, solve the equation. So first you need to create a solve equation, and then you want to solve this with respect to, right, your variable a, right? So that you can also get by using this particular variable here. So you want to solve with respect to a, then you will get a solution. You want to solve with respect to b, then you will get one more solution. So like this you can repeat it for multiple. So sol b, okay, equal to same, this you need to copy and paste here, and you need to solve it with respect to b. So this is solve b, and you want to solve with respect to c, so you just need to copy this entirely and paste it. And in place of b, suppose if you want to place c in both the places, now you will have a solution for all. So you can see how quickly we are able to give the solution for the a, b, and c, right? So this will be more easy for the scientist to find the solution and come up with some relevant idea based on which they can implement some reaction methodology, and that is how they achieve this. And at the end they won the Nobel Prize for that particular analysis, and they were a lot happy. So coming to this summary part, like what we did cover in this particular video is MATLAB offers this solution or solve part, which helps you solve multiple equations, which also helps you to simplify multiple equations that are available, which you created by yourself, right? So those can be solved very quick, and suppose once you solve this, you want to evaluate it, and you want to calculate something, that will be more faster. So because of that, the symbolic toolbox can be used in an efficient way, and you can implement it to your real problem that you are facing while solving any equation, and you can come up with the solution in a better and quicker way, so that you can discover something. So in case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. We will be more than happy to clarify your doubts. Have a great day ahead. Thank you.